Good. Hello, everybody. Today kind of marks the beginning of our climate change unit. This is my favorite unit in a normal year because there's so much information that we learn over the course of the year that allows us to understand the content in this unit. We're going to be using the chemistry that we've learned to take a deeper level of understanding into climate change than you may have had in other classes. Additionally, because we are approaching the end of the year, rather than try and cram a bunch of information in all at once, I am only going to be choosing a couple of choice lessons that I've done from previous years. So, pros and cons, it's not going to be like crazy busy, but we're also not going to get to learn as much about climate change as other years have. Okay. Before we get into climate change, we do need to take a little bit of time to just talk about what the greenhouse effect is. Basically, the greenhouse effect is the reason why climate change happens. So the greenhouse effect is the cause of all the other climate change related issues, and it's basically formed at the molecular level. So we're going to be talking about the science of the molecules. Why do certain molecules do things that can have negative effects? All right. Our target today is to be able to identify why certain molecules, particularly greenhouse gases, produce a greenhouse effect. So you guys may have heard of greenhouse gases, things like carbon dioxide or methane, but there are actually a lot of different greenhouse gases, chlorofluorocarbons, SOx and NOx. Water vapor is actually a greenhouse gas. And these greenhouse gases are causing the atmosphere to warm up, and that's creating a lot of different problems. So we're going to talk about why does that happen. Okay. There's going to be about 4 or 5 different PowerPoint slides, excluding this one that we're going to go through today. Rather than writing down every single detail on each slide, I just want you guys to write down 2 to 3 main takeaways that you got from each slide. That's going to reduce the amount of writing that you have to do considerably, but it's still going to help you retain the most essential pieces of information from each slide. And I'm going to kind of give that up to you, that choice up to you as to what you think is the most important takeaways for each slide. All right, let's get into it. So I thought that we'd take a little bit of time and just kind of talk a little bit about greenhouse effects and talk about greenhouse gases by doing some true or false statements. So I've got a bunch of different statements up here on the board, and I'll read them off to you one at a time. And I want you to decide for yourself if you think those statements are true or false. And then we'll use scientific textual evidence to determine if they are true or not. If you want to see the textual evidence that I'm using to get this data from, just let me know and I can send that to you. Okay, so statement number 1, the greenhouse effect is good for our planet. Do you think number 1 is true or false? Turns out it's actually true. The greenhouse effect is very important for our planet. We would not be alive if it wasn't for the greenhouse effect. See, the greenhouse effect keeps our planet warm. If there was no greenhouse effect, this would be an ice age right now. The problem with climate change is that if there's too high of a greenhouse effect, the planet becomes hot, and that's not very good for life either. Okay, next one. Molecules of greenhouse gases consist of at least 3 atoms. Think of the greenhouse gases you know. I mentioned a couple of them at the beginning of the video. Carbon dioxide is the one that typically comes to people's mind. Do any of those molecules have fewer than 3 atoms? And feel free to go back towards the beginning of the video if you want to double check. Okay, so all greenhouse gases have at least, at minimum, 3 atoms. And we'll get into the why a little bit more in the video, but for right now, it gives the atom different ways and more ways to vibrate. That's effectively what's causing the greenhouse effect. It's whenever an atom vibrates back and forth, that is an atom that is hot, right? Vibration equals heat. All right. Statement number 3. Greenhouse gases absorb, take in, and re-emit, send out infrared radiation, which is just light. So greenhouse gases, like carbon dioxide, are absorbing, they're taking in, they're releasing light, which causes the molecules to stretch and bend. Do you think that's something that happens? If so, you would be correct. See, what happens is sunlight enters into the atmosphere, it gets absorbed by these greenhouse gases, the greenhouse gases vibrate back and forth, and they also re-emit some of that infrared radiation into other greenhouse gases, causing them to vibrate as well. Okay, carbon dioxide is the most effective and most abundant greenhouse gas. This is actually not true. Chlorofluorocarbons are a very dangerous type of greenhouse gas. There are not many of them left. The federal government has done a good job of making it so that they're not being created. These are not things that are made in nature. Chlorofluorocarbons are made in factories, or they used to be. They have been strictly banned since, just because of how powerful a greenhouse gas they are. Water, oddly enough, it's so weird to think about, but water vapor, like in the clouds, is actually a greenhouse gas as well. And it is the most abundant. There's a lot of water in the atmosphere. Speaking of clouds, high clouds trap less infrared radiation. They trap less light than low clouds. So obviously the atmosphere, it's very big. Do clouds that are high up tend to trap less light? If so, then the statement is true. Okay. So this statement is oddly enough false, and here's why. Clouds that are really high up, they are closer to the sunlight. So they're going to get hit by the sun's infrared radiation first. Lower clouds are going to receive the light that passed through the higher clouds. And because they're made of the same thing as the higher clouds, rather than absorbing more light, they simply bounce the light back and forth between clouds of different layers of the atmosphere. Some carbon is sequestered by tropical forests and boreal forests. Sequestered basically means stored. So can carbon be stored in forests? Yeah, it absolutely can. Boreal forests, which are just really like kind of tundra-based forests, are very good, as are frankly tropical forests like the rainforest, are very good at trapping carbon dioxide in. See, trees, they photosynthesize, right? We know what photosynthesis is from biology. The trees and the plants are sucking carbon dioxide out of the air and turning it into glucose. So all that carbon dioxide gas that was in the air that's contributing to the greenhouse effect is now trapped in trees on the ground where it doesn't contribute to the greenhouse effect. And this is a very good thing because there's too much carbon in the atmosphere right now. With the exception of CO2 and H2O, we can control which greenhouse gases get into the atmosphere. True or false? Can we control most of the greenhouse gases? We absolutely can. Human beings naturally produce carbon dioxide and water, right? When we exhale on our breath, there is carbon dioxide molecules and water molecules. But other greenhouse gases, like methane gas and the deadly chlorofluorocarbons and dirty ozone and others like SOx and NOx, these can be prevented by mankind. Okay. And I would say that carbon dioxide can be greatly reduced as well. Okay. So take a little bit of time, identify, there's a lot of different statements here. Which ones are the most important to you? Choose 2 or 3 that you think are really important and write them in your notes. Feel free to pause the video if you need to. I'm going to move on though. For you visual learners out there, here's a quick picture that describes what happens when sunlight enters the atmosphere. So sunlight comes into the atmosphere, it gets trapped by greenhouse gases. Those greenhouse gases absorb that sunlight, causing them to vibrate, and vibration equals heat, and then they also re-radiate that energy, that heat, that sunlight into other greenhouse gases, causing those greenhouse gases to vibrate. Basically, as more greenhouse gases enter the atmosphere is basically becoming a better insulator. Not necessarily a thicker blanket, just a blanket that traps in heat better. Okay, what is the greenhouse effect? How does it operate? So basically, light and heat are entering the atmosphere, but greenhouse gases trap them. Why are greenhouse gases so good at absorbing sunlight? It's because they have more ways to vibrate. See, light, there's a lot of different kinds of light. There's red light, blue light, green light, infrared light, ultraviolet light, light. So many different kinds of light. And some molecules can absorb many kinds of light, and some molecules can only absorb one or two. And it turns out that the bigger a molecule is, the more different kinds of light it can absorb. So molecules like carbon dioxide, like water that have 3 atoms, they are better at absorbing light than molecules like nitrogen gas excuse me, and oxygen gas, which can only really absorb 1 or 2 kinds of light. How do these molecules do it? Basically, imagine that this little blue thing, this coaster, is an atom, and my fists are atoms, right? So the blue coaster is an oxygen atom, my fists are hydrogen atoms. What happens is when light hits this, there are 3 ways it can vibrate. It can vibrate like this, it can vibrate like this, and it can vibrate both the hydrogens out at the same time. So it can have 3 different kinds of vibrations, absorbing 3 different kinds of this infrared light. Last slide. What determines how good a greenhouse, what makes a greenhouse gas more dangerous than others? Okay. So some greenhouse gases can absorb more kinds of light. This is an understanding of their effectiveness. Carbon dioxide is a mediumly effective greenhouse gas. It can absorb 10 times as much sunlight as a water atom can. It's just better at it. However, water is 30 times more abundant than carbon dioxide, so it also has a very big impact. My personal research, one of my areas of research, is on methane. So methane is 720 times as effective of a greenhouse gas than water, or 72 times as effective a greenhouse gas than carbon dioxide. And my strategy for stopping climate change revolves around methane reduction, or stopping the production of methane, effectively decreasing my carbon footprint through methane, because methane is so much more effective than carbon dioxide or water, and it has such a higher impact on a molecule-for-molecule basis. If I can remove 1 ton of methane from the atmosphere, that's like removing 720 tons of water, or 72 tons of carbon dioxide. It's a very large impact for very little effort. Win-win. Okay. Last takeaway from these slides today is a carbon sink is basically the same thing as a carbon trap or a forest, right? There are a lot of different carbon sinks in Earth. These carbon sinks are really good at trapping carbon. However, it is very easy for that carbon to be mass released. For example, when a forest traps carbon, if that forest burns, all of that carbon suddenly gets re-released back into the atmosphere, and that's really bad. Something that we're going to be talking a lot about is something called the permafrost. The permanent frost, ice, is a permanent layer of ice that covers much of the northern part of North America and the southern part of South America. So anywhere where it's a cold climate, you're going to find some of this permafrost. And this permanent ice is trapping a lot of carbon, methane and carbon dioxide and other kinds of carbon in the ground where it's been for millennia. And as the Earth gets warmer, that ice is starting to melt. And you can kind of imagine what's going to happen. And if you can't, that's okay. We're going to talk more about it later. Cool. This concludes our kind of introductory understanding into why climate change is happening. It's really not up for debate. If it is, this is how it is happening. There you go. I'll catch you guys more tomorrow with a little bit more information.